We've spent a few days talking about some theory about gravity. Time now to do some math regarding gravity. Okay, now you will find that almost all of these problems really are exactly the same as the ones that we did at the tail end of the second unit. Just rather than things moving sideways, they're going to be moving up and down. So it's really just a review of that in a vertical sort of situation. So, quick reminder of some formulas. We got FW equals mg. We got G is not really a formula, but the constant G is 9.8 meters per second squared. We got, right away I see a problem here. Let me just check yours. Yeah. You guys see a problem there on mine? Yeah, the V bar, this should be a D, right? I think you guys have it proper on yours, am I right? Yes. So V bar is D over T, delta V is VF minus VI, V bar equals VI plus VF over 2, and A equals delta V over delta T. Okay, we're all good on all of those, I think. Okay, so let's just jump right in here. So the demon drop is a ride at an amusement park. You watch it and you time its free fall time at 1.5 seconds. So being the physics nerd that you are, you stand there at the fair and you get out your phone and you time how long it takes for the thing to fall. Who else has ever done that? So, just me, I guess. I actually did it once. Yeah. I want to know how tall it was. You watch it and time its free fall time at 1.5 seconds. How fast is it going when it reaches the bottom? So what are we trying to find there? How fast it's going? What of the variables are we trying to find? How fast is it going when it reaches the bottom? The answer is not 0 once it lands. I'm talking about like the impact speed. We're solving for the VF, the final velocity. Right? And what do we know? We know the time. Anything else that we know? It starts at 0, that's good. VI is 0. You'll notice that it doesn't actually come right out and say that, does it? You have to understand that it's going to be dropping initial velocity 0. There's one more thing that's not stated. And that is the acceleration, which is minus 9.8. Right? So those are the things that you know, and that's what you're trying to find. So we're trying to find VF. Now the only formula that's got VF in it, well, that one, right? We got nothing about, we got VI, but I don't know the average, so I can't find that one. Which one can I work with to begin with? I know the A and I know the T, right? With A and T, what can I find? The change in velocity. So let's start with that. A equals delta V over delta T. Oh, and by the way, a reminder to many of you that writing the formula is a good thing. You're not saving time by not writing it. You're saving marks by writing it. Start thinking that way, because it will help you. The acceleration is minus 9.8. Find the delta V. The time, that's a delta T. Let's write that so we can read it. The time is 1.5. Now, I've also said that you guys need to be able to solve these kind of problems without even thinking. There's still 1 or 2 people that are having trouble with the math part here. Okay? You're going to multiply 1.5 times minus 9.8. 14.7, right? Minus 14.7. But that is the change in velocity. That is the delta V. Right? And so now you got to go delta V is VF minus VI. Oh, but because the VI is 0, what happens? Right? So, can you skip that step? Probably, as long as you tell me that you know why. Okay? So the final velocity is 14.7. That's how fast it's going when it reaches the ground. Everybody with me so far? How high is the ride? So we're looking for what value? We're looking for distance. Right, Jason? So which V do I use? I use V bar. So what number is that? Is that the 0? Is that the 14.7? Or something completely different? Something completely different. Because the 14.7, when does it actually become 14.7? Not until it gets to the ground. It's not going to 14.7 as it's falling. It never actually gets to 14.7 until it instantly touches the ground. Okay, so you have to find the average. V bar is VI plus VF over 2. The average is 0. VI is 0 plus minus 14.7 divided by 2. And you get 7.35, I think, right? Minus 7.35. That's the average. That's what's in the middle. And now you can go V bar equals D over T. Minus 7.35 equals D. Time is 1.5. And again, you're multiplying. And you get 11.025 meters. Probably 4 marks there. Any questions?
Where did your minus go when you found this?
It sort of disappeared, didn't it? Excellent question. I wonder if I did that on purpose. Really, the D stands for displacement, and it should be negative. You're 100% right. The D should be negative, and it just means that that distance, that 11.025, is actually down, so it's negative, right? But the question does say how high is the ride, so I guess that's probably why I just left it. Yeah. There are times when you can sort of let it slide. Good question. Okay. Example number 2. We got a tennis ball thrown upward with an initial velocity of positive 22.5. It's caught at the same distance above the ground from which it was thrown. So you throw it up, and you catch it at the same height, right? So the overall vertical displacement is 0, is what they're getting at there. So this ball goes up, and it comes down. How high does the ball rise? How long does the ball remain in the air? So that 22.5, well, that's actually the initial velocity. Anything else that we know? Again, we know we don't know the time, do we? We do know the acceleration, you're right. Minus 9.8. Anything else, Trent, that we know? There's one more unstated thing that you can figure out. Anybody know? The displacement is 0. You are correct. That's not the one I was thinking of, but you are correct. Why is the displacement 0? Because it ends up at the same height, right? Good point. There's one more unstated thing that's pretty crucial. I'll give you a hint. So go ahead, Sarah. The final velocity is 0, like at the point right there? When I throw something up and catch it, is it going 0 when it hits my hand? Like if it was going 0, it wouldn't be moving, right? But it's clearly moving when it hits my hand. No, on impact, not after the catch. On impact. There is another place when the velocity is 0. Where is that? Right there, at the peak. At the peak, the velocity is 0. What would that be? I'm going to call that the VF. It's the final velocity of the trip up, isn't it? Or I guess you could think of it as the VI is 0 on the way down. So we're going to break it into 2 parts. Okay? You guys had some good ideas there. That was good. So how high does the ball rise? So I need to find the displacement up, so I need to find the average velocity up, don't I? Right? So V bar equals VI plus VF all over 2. The initial velocity is 22.5. The final velocity on the trip up is 0, which makes the average 11.25 meters per second. And now, given that, can I move this over? And now, given that, V bar is equal to D over T, 11.25 D. Oh! We don't have the time, do we? No. How am I going to find the time? What other formula has time in it? Yep, the A equals delta V over delta T, right? I know the A, I'm trying to find T, but I don't know the change of velocity, do I? Can I figure out the change of velocity? I sure can. Delta V is VF minus VI. What's the final velocity? 0. The initial is positive 22.5, and we're subtracting it though. So yeah, the delta V, that makes sense, is minus 22.5. Because it goes from 22.5, it goes up, and it ends up at 0. So it changes by minus 22.5. And now I can do this. And that's going to solve for my time, right? Now here's one of those other math problems that kids struggle with. Is how to solve that one. And you got to know how to do that. T is equal to minus 22.5, and you're dividing by minus 9.8. And you have to get a positive value, right? Time must be positive. I get 2.3 seconds. But that's just the time what? That's just the time up. But part A still says how high does the ball rise? So now I think I can solve that. This seems to be a long question, doesn't it? Average 11.25 D time 2.3. This one's going to be positive. 25.9. Four steps to get there. Make a note, a mental note. When you get to grade 12, these kind of questions get a whole lot easier because I'm going to give you the formula. But you can't use it until you know how to derive those formulas. So we'll get there. 25.9. How long does the ball remain in the air? Oh. Well, if it's 2.3 seconds up, is it 2.3 seconds down? No? Colby, why not? So what you're saying is, like I throw it up in the air, and you're right, it slows down on the way up, and it speeds up on the way down, but like the time up? Is the acceleration thing going up as it is down?
No, because you're isn't there a stronger force acting on it when you're slowing it up? Or with the gravity?
Okay, well, that's true, but I'm asking if the time up is with time now.
Yeah, it's on the same spot.
That's true. Like once I release it, what is the force on it? Only gravity, right? It's only only gravity. And what is that? Is it not minus 9.8? It's minus 9.8 on the way up, and isn't it? Minus 9.8 on the way down, is it not? It's just that sometimes going up it's slowing down, but coming down it's speeds up. The time up and time down are the same thing. Provided that there's no air resistance. When you start talking air resistance, it gets a little bit wonky. But for the most part, the time up and the time down are the same. So I'm going to say the T total time is just going to be 2.3 plus 2.3, or if you prefer to multiply, 4.6 seconds. What if instead of catching it at arm height, what if I throw it up here, but let it hit the ground? Is the time up equal to the time down? How come? And it's going farther, right? It's going farther. Exactly. Okay. Anybody been to Canada's Wonderland, North Toronto? Okay.
So your acceleration is always going to be 9.8 these questions?
Yep. Unless, Jason, there's some other force, right? Like if you're, you got a rocket, right? A rocket actually launches and still pushes, right? So it's not slowing down after it, right? So yes, most of the time. Okay. Anybody went to Canada's Wonderland, North Toronto? Nobody? Oh, yeah. It's a lot of fun, eh? Got the water park on the other side there. They do have a drop bar like this. I have to admit, this is the place where I stood down and went, I wonder how tall that is. So I timed it. And then I did the math and figured out how tall it was. And then I went on there and I checked my work and it turned out I was pretty close. Pretty proud of myself. So it actually is 70.1 meters tall. How fast are you going when you reach the bottom of the ride if it takes you 3.8 seconds to complete the ride? So it just drops you and then lets you fall, and then it starts slowing you down so you get close to the ground. Right? But if it didn't, how fast would you hit the bottom? Okay, so what do we know? We know the displacement, right? We know the distance, 70.1. How fast are you going? What are they asking for? No, how fast are you going? They're asking for the final velocity. I still get the sense there's a few people that don't know the difference between acceleration and velocity. Velocity is how fast you're going. Acceleration is how fast your speed changes. Those are two different things. So you're not sure of what the final velocity is. You know that the acceleration is minus 9.8. And you know that the time is 3.8. And you're solving for VF. Say again? And the initial velocity is 0. I was just about to say, I think there's one more thing. Okay, so I need to find one with VF in it. Well, VF, delta V equals VF minus VI. If I can find the delta V, that would work, right? I think that'll work here, won't it? A equals delta V over delta T. So 9.8 times 3.8. 37.24. Is that going to be negative?
Yeah.
Why is it negative? Because you're coming down, and the velocity is increasing, but it starts at 0, and it's going to be a negative velocity when you get to the bottom, right? So in fact, because the VI is 0, have I shown you the 3 dots? 3 dots in a triangle. Therefore, the VF is minus 37.24. Oh, that's all there is to it, right?
Yeah.
Did I even need that D value? I don't think so. Well, will that happen occasionally? Will you get a number that you won't need? Nope. Absolutely. Ready to try one? How about you guys try the first one? I gotta do attendance. Try part A. Do you have a whole page to work with? Okay, so go ahead, try it. You got lots of room to make a mistake. I'll give you a couple minutes, and I'll come back and we'll do it. I'm going to do this right away. Can you wait a minute or two?
Sure.
Is this one hard? Oh, I left the recording. Is this one hard? Just a little? That sounded like, The D is 70. How far will it have fallen after 1 second? Oh, so we're given a D value, but then we're asked a D value. Is that right? But does the 70 meters mean anything? Doesn't mean anything here, right? They're just asking you how far. In fact, if I drop this ball from my hand, how far will it fall in a second? It'll be the same distance than if I went to a 70-meter tower and dropped it, right? The height that I'm dropping it from makes no difference. The time is 1 second, and what's the acceleration? Minus 9.8, and what's the VI? 0. So is this not literally the same as this? Is it not exactly the same when you boil it down? Because the V doesn't matter, right? I think it's exactly the same. A equals delta V over delta T. Minus 9.8 is equal to delta V over 1 second. Oh, this is going to be easy. I'm not even going to need a calculator. Minus 9.8. Oh, but I got to know how far. I need to know the... Oh, yeah. This one was, how fast are you going? Now I've asked, how far? Oh, I got to do something else here, right?
But I don't know what you're changing velocity.
You do, and does that tell us the VF? It does tell us the VF. Now notice that it's 9.8. Don't think of that now as acceleration. It's still velocity, right? You can have a velocity of 9.8. It's not a special number in any sense, the number itself. But now I need to get the displacement, I'm going to have to find the average, aren't I? I'm going to have to find the average. So V bar equals VI plus VF over 2. 0 plus a minus 9.8 all over 2. That's minus 4.9. Right? So the average is minus 4.9. And now you go V bar equals D over T. Minus 4.9 is equal to D 1 second. It drops 4.9 meters in 1 second. Does that make sense? If I drop my foam ball from a seating position like this, how far does it fall in 1 second? 4.9 meters?
Yeah.
Well, it would if I had 4.9 meters to work with, but I clearly don't, right? So therefore, we know that it takes less than a second to drop. Right? So that 70 actually does matter. Because, you know, if this value is more than 70, it ain't going to fall the whole distance. How far will it fall after 2 seconds? What do? Literally exactly the same. How much room you guys got? Oh yeah, small writer over there. It's literally the same thing, right? Let me do this quick here. I got this ability. It's my superpower. What changes? The 1 becomes a 2, right? Minus 19.6. Minus 19.6. This one here is stupid because you end up, yeah. You end up multiplying by 2 and dividing by 2 over and over. I'll pause there for a second because I got one more thing to say. The last question says, how far will it fall during the second second? Kari, are you watching here? During the second second. Well, what is the second second? Well, if the time starts at 0, and then 1 second and 2 seconds, what is the second second? That's the first second, and that's the second second. So in other words, how far does it fall between 1 and 2 seconds? Well, how far has it fallen after 1 second? 4.9. After 2 seconds, this 2 is actually way down here, isn't it? How far has it fallen from the top down to 2? Minus 19.6. So how far has it fallen during the second second? 19.6 minus 4.9, which is? Does that make sense? How come it falls, 14.7, how come it falls farther in the second second than it does in the first second? Because it's accelerating, exactly. It's speeding up. It's going to be going farther, faster. Okay. Give me a problem set to work on. There's answers, there's solutions. You got about a half an hour, roughly. Enjoy. Kind of smelly.
Smell that smells smelly.
I don't do that.
I'm smelly smelly.
Oh. I had someone say to me it smelled funky, or no, it was funky in here. Did I get everyone? Yes. There's a couple questions on this starter set, by the way. Questions 6 and 7 have the word weight on them. I haven't done weight questions yet, so you'll have to leave out 6 and 7 for the time being.
Yeah. Like from 6:30
Go ahead and start, Colby, anytime.
I